we've met the 5 tribes of machine learning. We've seen that each one of them has a problem that it can solve better than all the others. And it has a particular master algorithm that solves that problem. So for example, for the problem that the symbolists solve that none of the others know how to solve is the problem of learning knowledge that you can compose in many different ways. Okay? And they learned that knowledge with inverse deduction, as we saw. Connectionists solve the credit assignment problem using backprop. Evolutionaries solve the problem of learning structure. Right? The connectionists just start with a fixed structure and just adjust the weights. The evolutionaries know how to come up with that structure in the first place using genetic programming. The Bayesians are all about uncertainty. They know how to deal with the fact that all the knowledge that you learn is uncertain. They know how to update the probabilities of hypotheses as you see more data. They use that using probabilistic inference, which is essentially computationally efficient ways to apply Bayes' theorem to very large sets of hypotheses. And finally, the analogizers, right, they can reason by similarity. They can actually generalize from just 1 or 2 examples, right? Think of Niels Bohr, right? He came up with the first, theory of quantum mechanics by doing an analogy between the atom and the solar system, generalizing from 1 example. None of the others can do this. And, one of probably the best known analogizer algorithm these days is kernel machines. But the thing that I want to point out is that precisely because each of these problems is real and important, none of the individual algorithms are enough. What we really need is a single algorithm that solves all 5 problems at the same time. We need, a grand unified theory of machine learning in the same sense that the standard model is a grand unified theory of physics or the central dogma is a grand unified theory of biology. And in fact, a bunch of us have been working on this problem for a while, and we've actually made a lot of progress. We know we're still far from the end of this, but let me just give you a sense of where we are at this point.